that had a flood. So a pipe had burst, at least that's what we were told, and it flooded the motor up to the peckerhead. We were actually supposed to be receiving a 700 horsepower DC electric motor from them, but that kind of fell through, and it's going to be a couple weeks, I think, before we see that come through the shop. So for now, we're just going to have to get our motor satisfaction video out of this little guy right here. So we can remove the key stock out of the keyway, we can pull the rubber flinger off of the shaft, we'll toss that into the parts pan, and we'll bust out some tools. No one ever believes that I still have my... oh, and you know what? I remember where I put it. I hide it here just so that it doesn't actually get lost, and I'll put it right back in there. So we have 3 bolts that pass through the face of this end bell that lock into the bearing retainer that will be behind the bearing, which we will see when we remove the end bell itself. I try to set things nicely in the parts pan so we don't damage any of the threads, and then we have 4 bolts that are holding this entire end bell on. So the trick to taking these end bells off is not how hard you can hit it, it's how evenly you can take it off. Meaning we really want to work from both sides evenly. We're going to need to use a hammer and a chisel or a punch or so. We'll create a little gap here that we can then fit a chisel like this in, and we will work both sides trying to pull it off as evenly as possible. At this point, it was time for the motor to take a bathroom break. And after that little break was over, you can see we created a decent gap here. We can keep prying to pull this end bell off. You want to be careful if you go wedging some sort of a pry bar in between that gap that your pry bar is not touching the winding, or you're going to damage that winding and it will have to be rewound. So I did mention that this was in a flood, so there was quite a bit of water inside of this. We're going to need to check these bearing fits, make sure that those are all within spec. But since we got that front end bell on, we can now redirect our attention towards the back. We're going to remove this fan cover. And there's a couple grease fittings on this we're going to remove so that we can get this fan cover off. And while I'm struggling to do that, I wanted to talk about the fan itself. Anytime you see a fan, the blades are angled a little bit, and depending which way you rotate that is which way it's going to suck air or push air. Now, a majority of electric motor fans that you see are not going to be angled unless the motor itself is only to be operated in a single direction. Now, I see a lot of motors come in and they don't have the fan cover on them, but this fan is throwing air outward, and then that fan cover is directing that air up and over and around the electric motor, and sometimes people ask me why they have all these fins on them. Well, those are heat sinks, and they increase the surface area so that we can cool the electric motor efficiently, and if you don't have that fan cover on, you're not going to be cooling this electric motor efficiently, and heat is one of the worst adversaries of electric motors. Once we have the fan and that key stock removed out, it's kind of the same process. We're going to remove these bearing retainer bolts, and we will be able to remove this entire end bell. A lot of people didn't like my torque multiplier pipe that I used last time, but what do you think about this setup right here? What do we call this one? Anyway, we're going to start pulling these studs out. These are what are holding our back end bell on. That stud extends out, and that's what the fan mounts on with the nuts that we took off earlier. Once we removed all 4 of those studs, it's kind of the same process again. We're going to try to create a little bit of a gap between the end bell and the motor frame itself. And we want to be careful because there's not a lot of shaft for this end bell to sit on. This end bell probably weighs 350, 400 pounds. You don't want that falling on your foot. Once I did create a little gap in it, we got another little waterfall out the front. Now, we all know that electricity and water don't mix, and I'm sure if you look down in the comments, there's going to be some guy that's like, "What do you mean electricity and water don't mix? Pure water is one of the best insulators." Well, this isn't water in pure form, so why don't you just sit down, Brian? What I did find interesting is all this little stuff right here that looks like hair is actually the enamel and the varnish coating peeling up and off the wires. And that opposite drive end bell did not want to come off, so I ended up pulling the entire rotor out. I set the thing on the ground, and bam, one whack, there she goes. I don't know if you've ever heard that old story of that guy that showed up and he tapped something with a hammer to fix it, but hey. But now that we got all the pieces and parts out, we can inspect each individual piece. We'll remove these bearings, we'll see what size they are. We'll use a micrometer to measure the shaft seats, we'll check the end bell fits, we'll move this winding over to our winding analyzer where we can do some electrical testing on this also. So this motor does have 6 leads coming out of it, and you can see they're all grouped in 2s here. So when we rewind stuff like this, we do need to pay attention that it's 6 leads. That doesn't mean it's 6 leads. It could be 1, 1, 2, 2, 3, 3. It could be 1, 2, 3, 7, 8, 9. But we need to make sure that we put it back exactly as it was when we got it. So I did stick this onto our winding analyzer, and we know that we had a bunch of water inside this thing, and it makes it up to about 75 volts, and it will not pass our megohm test. Now, that's extremely common, so then what we can go ahead and do is we'll pressure wash the inside of this thing, we will clean it, and then we will dry it out. This is just our fan cover, weighing 152.5 pounds. I was going to make lunch. I didn't know if I wanted Freezy Pops or pizza, but I decided on the pizza because the last time I put Freezy Pops in the pizza oven, I got in trouble. So these are the tolerances we're dealing with these bearing fits as well. A 6318 is 7.4814 to 7.4803. There's not a lot of room for error in these. Both of these end bells are bad, and we possibly will be winding this electric motor. Cheers, guys.